Hello, good morning, whatever time it is for you. Today we're going to talk about solving some exponential equations. There are two ways to solve exponential equations. One way is to make the bases the same. So if we can make this number here and this number the same, so if we can make the bases the same, okay, if the bases are the same, then the exponents must be equal. So rather than solving this equation like this, we're just going to solve the exponents, or rather solve the exponents, because we're going to set the exponents equal. So 3 to the x plus 4, I can write 27 as 3 to the third power. So if 3 to the x plus 4 has to equal 3 to the third, that means that x plus 4 must equal 3. Okay, in order for this to be true, in order for these numbers to be the same, this exponent must be equal to 3. So we solve this by subtracting 4 from each side, and x has to be equal to -1. So one way to solve an exponential equation is to make the bases the same. When the bases are the same, the exponents have to be equal. Okay, but that's not always the case. But you can always do this method. So notice this is a 7, and there is no way that we can write 25 as 7 to some power. Okay, that's not true. 7 to the first power is 7. 7 squared is 49. So that is not true. So one thing we can always do is take the natural log of both sides. And this is good even for ones that we can write as the base. If you take the natural log of both sides, we can proceed with some laws of exponents. So the first step here is to take the natural log of both sides. So we write natural log here and a natural log there, which leaves us with this equation. The natural log of 7 to the x minus 4 power is now equal to the natural log of 25. So one of our rules of exponents says that if we have a log of something to a power, we can take the power and change it into a product. So the power property of exponent says that we can take this power of this exponent and change it into a multiplication. So x minus 4 times the natural log of 7 will now equal the natural log of 25. So we have taken the exponent, or the variable, taken the variable out of the exponent, and now it's in a nice multiplication. So we solve multiplication by dividing, so we'll divide both sides by the natural log of 7. Okay, we're going to have to get a calculator to do this. Let me see if I have a tool that has a calculator, so I can do it right here on the screen. On-screen keyboard. On-screen keyboard, maybe so? Nope, that's not it. So I'll just have to do it on a regular calculator. Sorry you can't see this, but I'm typing in the natural log of 25 divided by the natural log of 7. That gives me the decimal 1.654174951. And we will carry all these decimals through for now, but in a minute we're going to just round a little bit. So this cancels out, so we're left with an x minus 4 equals 1.654174951. We add 4 to both sides. Let's add it here, 4.0. So x equals 5.6542. So we'll finally round up to the 4th decimal place. The 7 makes the 1 become a 2. So rounding to 4 decimals gives me an x value of 5.6542. So taking the natural log of both sides allows us to take the power and make it into a product so that we can solve this nicely. Okay, one more example. Here we have a relatively tricky one, so let's do this together. First we're going to do, of course, is take the natural log of both sides so that we can use the property of logs to bring the exponent in front. So the natural log of 4 to the x plus 3 is equal to the natural log of 12 to the x minus 2. So we're going to take both of our powers and move them in front to become products. So x plus 3 times the natural log of 4 equals x minus 2 times the natural log of 12. So here we have some number. Remember, the natural log of 4 is a number. The natural log of 12 is a number. If you type it into your calculator, what you get out is a number. It might be a decimal, but we can still treat it like a number. So I'm going to distribute this number into both of these parentheses, and likewise over here, distribute the number into the parentheses. So I have the natural log of 4 times x plus 3 times the natural log of 4 equals the natural log of 12 times x minus 2 times the natural log of 12. So remember, all of these things are numbers. This is a number. It's a nice decimal number. This is a nice decimal number. So I can add numbers together. We're solving this for x, so we're going to get our numbers on the same side. Okay, and that gets rid of this one over there. Likewise, I'm going to do a similar thing with this one. I'm going to subtract the natural log of 4x from both sides. Okay, which gets rid of it there. So if I do this in my calculator, if I have 3 natural log of 4 plus 2 natural log of 12, let me just put that into my calculator real quick so I can bring it up. Maybe see if I can do this here. Nope. Okay. The 3 natural log 4 plus 2 natural log 12. This is a decimal, 9.128696. And over here, if I do the natural log of 12 minus the natural log of 4, that's how many x's I have. It's not the natural log of 12 minus 4 is natural log of 8, but it's this. So my calculator says that the natural log of 12 minus the natural log of 4 is this decimal, 1.0986122. So now if I want to solve this, I have to divide both sides by my 1.0986122. Dividing over here, likewise, 1.0986122. My calculator says that the answer is 8.309. So a little bit more involved when we have two exponential equations and they both have variables in their exponent.